Hi, Assalamualaikum and good day. Today we are going to learn on how to solve problems involving the application on first order ODE. This is the objective of our lesson. Hopefully, by the end of this session, you are able to solve problems involving the application of first order ordinary differential equation, which are chemical mixture problems and RC/RL circuit problems. Let's proceed with the chemical mixture problem. Consider a tank which initially holds V0 liters of brine and A kg of salt. A brine solution containing B kg of salt per liter is poured into the tank at the rate of E liter per minute, while simultaneously another solution leaves the tank at the rate of F liter per minute. The problem is to find the amount of salt in the tank at any time t. By letting the capital Q be the amount of salt in the tank, dQ over dt is referred to the rate of salt in the tank. dQ over dt is equal to the rate of salt that runs in minus the rate of salt that runs out the tank. Therefore, to solve this problem, you need to apply the following formula: dQ over dt plus QF over V0 plus E minus F multiplied with T equal to BE. Bear in mind, you need to remember this formula, otherwise you cannot solve the problems. Now, refer to example 21. A tank contains 200 liters of brine made by dissolving 20 kg of salt. Water containing 0.25 kg of salt per liter runs in at the rate of 8 liters per minute, and the mixture runs out the tank at the rate of 4 liters per minute. Find the amount of salt in the tank at the end of 40 minutes. To solve, first of all, you need to identify the 5 items. V0 is 200, A is 20, B is 0.25, E is 8, and F is 4. Make sure all the 5 items are correct. If one of these is wrong, the whole thing will be wrong. Substitute these items, except A, into the formula of dQ over dt plus QF over V0 plus E minus F multiplied with T equal to BE. Simplify, you will obtain dQ over dt plus Q over 50 plus T equal to 2. This is actually referred to the first order linear equation in which Pt is equal to 1 over 50 plus t and Qt is equal to 2. Next, find the integrating factor Ft, which is equal to exponent of the integration of Pt with respect to t. As Pt is equal to 1 over 50 plus t, integrate this, you will get ln 50 plus t. As exponent lns comes together, this can be simplified to 50 plus t. Substitute the integrating factor into the formula of Q, which is equal to 1 over Ft, multiply with the integration of Ft Qt dt plus C, you will obtain 1 over 50 plus t multiply with the integration of 50 plus t multiply with 2 dt plus C. Expand the function first, then integrate. You will obtain Qt equal to 1 over 50 plus t multiply with 100t plus t squared plus c. If you notice, just now we have not used the a. So a will be used here to determine the value of c. As A is equal to 20, that means Q is equal to 20 when T equal to 0. Substitute this into the formula that you have obtained just now and simplify. You will get C equal to 1000. Substitute the C value back into the formula. You will get the expression of the amount of salt at any time t. To find the amount of salt at the end of 40 minutes, you need to replace the t in the formula with 40 and simplify. You will get the answer for the Q is 73.3333 kg. Make sure you write down the correct unit in your final answer. Refer to example 22. A tank initially holds 100 liters of brine solution containing 1 kg of salt. At t equal to 0, another solution containing 1 kg of salt per liter is poured into the tank at the rate of 3 liters per minute, while the well-stirred mixture leaves the tank at the same rate. Find the amount of salt in the tank at any time t and the time at which the mixture in the tank contained 2 kg of salt. First, identify the 5 items. Here V0 is 100, A is 1, B is 1, E is 3, and F also 3 because of the same rate. Substitute the item except A into the formula and simplify. You will obtain dq over dt plus 3q over 100 equal to 3. As this is linear equation, you need to find the integrating factor ft equal to exponent of the integration of pt dt. As pt is equal to 3 over 100, which is a constant, integrate this, you will get 3 over 100t or 0.03t. Therefore, the integrating factor is equal to exponent of 0.03t. Substitute the answer into the formula of Q equal to 1 over Ft multiplied with the integration of Ft Qt dt plus C. You will obtain 1 over exponent of 0.03t multiplied with the integration of exponent of 0.03t multiplied with 3 dt plus C. Integrate and simplify. You will get Q equal to 100 plus C exponent of negative 0.03t. As A is equal to 1, that's mean when t is 0, Q is 1. Substitute this into the formula of Q that you have obtained and simplify. You will get C equal to negative 99. Substitute the C value back into the formula. That is how you get the expression of the amount of salt in the tank at any time t, which is represented by Qt equal to 100 minus 99 exponent of negative 0.03t. To determine the time at which the mixture in the tank contained 2 kg of salt, you need to replace the Q in the formula with 2 and simplify. You will get small t equal to 0.33 at 4 minutes.